Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome back. Today we're going to be working with modeling with equations. And the whole point behind this is just to get comfortable with changing word problems and thinking into mathematical equations. I know not all these scenarios are something that you may actually calculate, but at some point in time you might come along something where you actually really need to utilize equations in your real career, so going ahead and getting basic for it is never a bad idea. So we're going to start off with something pretty simple. A car company is going to charge you $70 a day and 30 cents per mile driven for each car rented. You rent a car for 2 days and your bill was $236. How many miles did you drive? So a lot of you are just going to read it just like that. And that is not going to be my recommendation. My first recommendation is to read the question. How many miles did you drive? Oh, I'm driving a car. Miles. That's my question. Once I have that, I know that I'm done. Okay. Well, what about this? Okay. So I like to use descriptive variables. A car company charges. So my cost, okay? My cost is going to be calculated by doing $70 per day. So times days. And 30 cents per mile. Okay, but this was in dollars and that's in cents, so I have to do apples to apples, and I really don't feel like writing 7,000 cents, so I'm going to write 0.3 or 30 times the number of miles. Okay, great. That's what we're looking for right here. And you'll notice that there's a punctuation mark here. That means we're at an end of a statement or an end of an idea. So we're done writing in that part. Okay, you rented a car for 2 days. We already know miles is our question, so I'll put an M for miles. And your bill was $236, so my cost was $236. Okay, great. Now this is a pre-algebra level question. Or we can go ahead and make that 70 times 2 is 140 equal plus 0.3 m. Okay, we'll subtract the 140 over. 96 equals 0.3 m. And now we're allowed to divide by 0.3. And we find out that we drove 320 miles over these 2 days. Okay, now some of you might have just been like, okay. So most of you probably were like, okay, 236 minus 70 minus 70. And then you get that 96, and then you divide by 0.3. And you kind of think it out logically. And that's very acceptable as well. I'm going through a way to approach it for those who maybe get stuck. Okay, so, and that's just what this is going to be, is just some different word problems. Okay, simple interest. Simple interest means there's no compounding. You only get interest once. Normally, with investments and stuff, you get interest every month. But if they tell you it's simple interest, that means you're going to take your principal, which is the amount you put in, times your rate as a decimal, and that's times your time in years. And most of the time when we see formulas, you should assume that time is meant to be in years. So how much interest, I for interest, is earned by investing 1,000, so that tells me 1,000 is P, times our rate. Now remember, 5%, we can't put 5% in here. We have to make it 0.05 because that's what 5% is as a decimal, for 3 years, so times 3 years. Okay, so now we're just going to go ahead and type this into a calculator, or if you happen to know what that is, then perfect. Many of you should be able to do that in your head by now. So anytime you take 100 times a decimal, it moves the decimal over 2 places. So we'd be at 5, and then when we take it times 3, we're going to get 15. So over 3 years, you're only going to earn $15 in simple interest. And again, that's not how your investments work. That's not how the interest you pay on a loan works or a credit card. But simple interest is just a basic formula. So let's break that up and let's take that a step further. Okay, you inherited $100,000 and you put it into 2 accounts. Now, sometimes when we invest, we don't know what result we're going to get, so we're not going to guarantee that you put more in the 6%. Maybe one account was more risky than the other. I don't know. One account resulted in a 6% growth, while the other resulted in a 4.5% growth. Using annual simple interest, you earned that year with a growth of $5,025. How much was your initial investment into each account? Okay, so we read it. We know what's going on. We inherited money and we invested it. So how much into each account? So here's a money bag. And here's a money bag. How much into each account? Okay. That's the question. How much in here? How much in here? We know when we put our money bags together, we get $100,000. And that's from this. You inherit $100,000 and invest it into 2 accounts, period. Okay, I've drawn an image to make that sound good. Sometimes I find images help students better than, okay, one account earned 6%. And the other resulted in 4.5%. This time I'm going to write it as a decimal instead of a fraction. Okay, and there's a period, so we finished that statement. Using annual simple interest. Okay, using I equals PRT. How much was your initial investment into each account? Okay. To get $5,025. Okay, so after the interest, they calculated the interest, and they calculated the interest, and they put them together. That was $5,025. The problem is that we don't know how much was put into these 2 accounts, and we may or may not know substitution, things like that. So think of it this way. You have $100,000 and you pour some of it into here. That means, since it's for 1 year, when we take our principal times our rate times our time, hey, that's helping us out. But I don't want to bring in another variable because I don't want to have to solve for too much. So if we poured some of our money into here, then the rest of it would go into here. So think about this. If you poured 200,000, or not 200,000, 2,000 into this, what would be left to pour into that? 98,000. How would you have gotten that? You would have subtracted 100,000 minus the 2,000. So what's in here to get poured into here is whatever's left after you started with this, right? After you poured some out. So that means our principal times our rate times our time. So the great news is we only have one variable, x. So we don't have to get super crazy with this. Now we're just going to clean it up a little. And I'm putting the interest in green because the actual true dollar amounts were in pink. So the pink is what you started with, the green is our growth. So 1 times 0.06 is 0.06 times x. Multiplying by the 1 really doesn't change anything, right? We have 6 zeros, so I'm going to move the decimal 6 times. So there's 3, 4, 5, 6. Oops, that was supposed to be a plus sign. All right, and then we're going to combine like terms. So when I do 6 cents minus 4.5 cents, that leaves me with 1.5 cents. I had an extra 0 on there, didn't I? Oh, that's because there was only 5 zeros. Haha. Why did I write 6 down that time? So this is one of the times when you want to make sure that you pay attention to how many zeros you have. So only move it 5 times. 1, 2, 3, 4, 5. That's why it's 4,500. Okay, we're going to subtract the 4,500 over. And then we can divide. And we get 35,000. What does that mean, though? Okay. How much was your initial investment into each account? So I need 2 answers because there was 2 accounts. But we just found out that X was 35,000. Okay, so if we put 35,000 in at 6%, then that leaves us with 65,000 to put in at the 4.5%. Why would you split it into 2 accounts if one's going to get a better percentage rate than the other? Well, probably because you can't always guarantee investments, and sometimes they don't come through. Maybe one had more risk or not. So keep that in mind that, yes, I know, but this was a math problem, not a real life problem. I get that, but it's kind of showing you how that you can split up stuff into 2 areas. So if it helps to draw a picture, draw a picture. So let's think about that again. We have a square garden with a 3-foot wide walkway surrounding its perimeter, period. All right, I'm just going to draw a garden. Make it a square. There's our garden. Okay, a 3-foot wide walkway. The area of the entire garden is 18,000 square feet. What is the plantable dimensions? And I did forget to write down the area of the entire garden, including the walkway. But we want to know how big is just our garden plantable, okay? So there's a couple ways we can do this. We can either find out the outer dimensions and then get the inner dimensions, or we can work with the inner dimensions to the outer. It does not matter to me. In this case, I think it is easier to start with the outer dimensions. So it's a square, right? So something times something is this 18,000. So the outer dimensions, x times x, is 18,000. So let's just find out how wide it is. It's approximately 134-ish, right? So this outer dimension is approximately 134 by 134 feet, because it did say dimensions. But we wanted plantable dimensions. This is with the walkway. So what would the plantable dimensions be? Well, it's a 3-foot wide walkway. Now, if you said 131 by 131, be careful, because let's think about this width. There's 3 foot wide over here on the right and 3 foot wide over here on the left. So the sidewalk, or the walkway being on both sides, actually adds 6 feet in width, not 3 feet. So that means the garden is going to be about 128 by 128, due to the fact that we have to take 6 feet off from the width and the length because the walkway occurs on both sides. Okay. Here we have another find its dimensions. So that means, you know, how long is it, how wide is it? It's a rectangle. So I know we have length and width. Okay. And we know our formula for area is length times width gives us our area. Okay. 8 foot longer than it is wide. So we have length and width, right? But the length is 8 more than the width. So you see how that, by doing that, that gave me one variable. So length times width, and you can commute those, I don't care which way, is 4,080. Okay. Distribute, and I'm going to pull that 4,080 over immediately. This is quadratic, which means I have to do the quadratic formula, or I have to factor, and I don't know how good you are at factoring. If I were to factor this, the first thing I would do is, okay, I would only try things smaller than this. So does 4,080 divide by 63? Nope. 62? Nope. 61? Nope. 60? Yes, and they're 8 apart. Okay, I could use that to factor. Let's say I didn't want a quadratic formula. I've already figured out a factoring. 60 times 68 is 4080. So W plus 68 and W minus 60. For those of you who like to solve by factoring instead of doing the quad formula, again, negative b plus or minus the square root of b squared minus 4c, we could have done it that way. And we're going to get two answers. We're going to get negative 68 or 60. For those of you who wanted to see the quadratic formula, so there's a 60. And there's the negative 68. So quadratic formula is very effective as well. My calculator does vertical fractions. Okay, so can the width be negative? No. So the width is 60 feet, and the length, W plus 8, would be 68 feet. So our building is 60 by 68 feet. And since this is a word problem, it is definitely important to label. We would not want to accidentally mess up and put our answers in meters when it was supposed to be in inches. Also making sure that your labels are the same throughout the problem. If they give you one dimension in yards and another dimension in feet, go ahead and make them both feet. Okay. A beverage manufacturer advertises their orange drink as being naturally flavored as it contains 5% orange juice. As soon as I see this, I understand the 5% orange juice tells me that we have some kind of mixture. Whether they've mixed water and juice or whatever, we have a mixture. They mix things together. New regulations, so we're just going to make this now 5% juice. That's from that first statement. New regulation stipulates that naturally flavored must contain 10% juice. Okay, so new is 10%. We want to add more juice, apparently, according to our regulations going on here. How much pure orange juice must be added to their current 900 gallons of drink to conform to the new regulation? Okay, so basically this company has a vat of 900 gallons of mixture that they're getting ready to bottle. And this has only 5% juice. Okay. And they're going to add pure juice, and of course we're not going to add a lot, to bring this up to 10% juice. Now, obviously, once we add some juice, by the way, pure juice would be 100%. Okay, so obviously in the end, we're going to have more than 900 gallons, right? So we have our percentage, we have our percentage, we have our percentage. We have gallons, but we don't know our gallons and we don't know our gallons. So let's just think of it. If you have 900 gallons and you add some gallons, then wouldn't you have your 900 plus what you added gallons? Make sense? And the thing is we're trying to balance out this juice, okay? So 900 gallons, only 5% of it is juice. Okay, so that means only 45 gallons are actually juice. The rest is something else. Water, whatever, right? So when we focus on just juice, we have 45 gallons of juice. Now 100% gallons, that's all juice, right? How many ever gallons are in there, that's how much juice we have. The other thing is 100% is 1 is a decimal and 1 times x, right? So here I did 0.05 times gallons. So percent times gallons, percent times gallons. So here I would have to do percent times gallons. Okay, so of the 900 already, that would mean we were at 90. Hey, this is something we can solve now. So all we did was percent times gallons plus percent times gallons equals percent times gallons. And the reason it was a plus is they were adding juice in. Some word problems have you emptying something out and adding something in. So you have to make sure that you draw that picture so that you understand whether or not what's leaving, what's coming in. So that might be like they start draining 10% saline, but they're adding 5% saline or something, who knows. So you just have to make sure that you understand what's going back in. So solving this, we'd subtract our 45 over, which would give us this. Subtract our 0.1 or 1/10. Okay, and now we can divide. And when we divide this, you're going to find out that it is 50 gallons. So in this situation, we should be adding 50 gallons of just pure, in this case, orange juice, to bring it up to compliance. So adding 50 gallons would be better than throwing out all 900 gallons and starting over. And so that's why they might want to look at this kind of a formula. How much do I need to add to get it? Now, how much total would they have to bottle then? They would have 950 gallons of their mixture to bottle, and all 950 gallons would now be in compliance. I know, word problems are your favorite thing, right? Okay. Working together. Okay, so how quickly can they accomplish the task? I wonder what this task is. Okay, so due to a heavy storm, the water level in a reservoir must be lowered by 1 foot. Okay, the faster you can do that, the less chance your levee's breaking, right? Spillway A could do this in 4 hours, and Spillway B can do it in 6 hours, so working together. We're not going to say 10 hours, because 4 hours plus 6 hours I know is 10 hours, but yeah, let these work 10 hours, then they're going to actually lower it by more than 1 foot. So how can we look at this? Well, A lowers it 1 foot in 4 hours. B lowers it 1 foot in 6 hours. So let's look at this after 1 hour. Okay? After 1 hour. Because we want to know what A and B have done together, right? So after 1 hour, if A can do 1 foot in 4 hours, then what can A do in 1 hour? Well, we'd have to do divide by 4, right? So A could do 1/4 foot. And similar, B could do, in 1 hour, could do 1/6 foot, right? So working together, they did 5/12 of it in 1 hour. That's almost 1/2 foot. So that means in 2 hours, they're almost to a whole foot. So it's going to be somewhere between 2 and 3 hours, which if you're trying to lower it quickly, that's probably the best thing, right? So 5/12 per hour times the number of hours to get you to 1 foot. So to figure that out, we can do 1 divided by 5/12. And that's 12/5. Well, what is that? That may not make sense to you, so 2.4 hours. That's one way to do it. The other way to do it is anytime you have a working together, you can do 1 job in 4 hours plus 1 job in 6 hours equals 1 job in X hours, or 1 foot in this case. And then I can multiply everything by 12x. So it gives me 3x plus 2x equals 12, 5x equals 12, x equals 2.4. And that's just another way of doing it using rational fractions. Same thing we did before, just looking at it differently. So the really big thing with word problems is sometimes you just need to draw a picture. Sometimes, you know, if you need to think of it as, you know, spillway A would drop at 1 foot in 4 hours. And think of your water spilling out. And maybe B is smaller, right? So the water coming out would take 6 hours. If that helps you. Okay, so working together, they're obviously going to raise the flow rate. Pictures are a great way to start off, diagrams. Can you do charts? Yes. If you're going to use a chart to do word problems, here's what I recommend you do. Okay, especially if there's more than one question. Read the question, not the problem, the question. Okay, meaning what do they want me to answer? So if there's going to be 2 variables, I've seen some like bird feeders and mailboxes. Sally and Bob. I don't know. Sally and Bob are making bird feeders and mailboxes. Sally takes this much time to do the painting. Bob does this much time to do the manufacturing. How many can they put out if they have this many hours, right? But how many bird feeders and mailboxes is a question. So bird feeders and mailboxes are going to be up here because they're the question. This is what we're asking, how many? So they're going to become my column headings, and I usually put the word total over here. And then information like Sally and Bob. Sally has 20 hours that can be dedicated. Bob only has 15. So if Bob spends 3 hours per bird feeder and 4 hours per mailbox, maybe Sally spends, maybe the bird feeders are more intricate to paint, maybe 6 hours, but mailboxes can be done in 3 hours. Okay? And then they might ask you how many can be done to maximize the revenue. Well, Sally doesn't have to work all 20 hours. Sally could work less than that, right? But we can call this X, this Y. And then bird feeders are our X, our Y, and 15 hours is the maximum time Bob can dedicate. So we're not solving that one because the point of this is not to do inequalities, but I wanted to highlight the fact that if you want to make like a spreadsheet type information, make sure your variables are at the column headings, and then your informational pieces, in this case it was Sally and Bob because they were the ones who could make it, are our side pieces. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.